In this lesson, we will explore the techniques available to reduce takeoff thrust when maximum performance is not needed. Whenever the greatest possible performance takeoff weight is required, the takeoff is accomplished using the maximum available takeoff thrust. The greatest possible performance takeoff weight would be needed typically on long-range flights carrying large payloads. Many times it won't be necessary to take off at the highest weight. Shorter flights or smaller payloads mean that the expected takeoff weight will be less than the maximum. When this occurs, there is no need to use the maximum available takeoff thrust. The decision may be made to take off at a reduced takeoff thrust. The greatest stress on an engine occurs during takeoff. During takeoff, the internal temperatures and the RPMs are the greatest. A takeoff performed at reduced thrust will reduce this stress significantly. This means that the engine will need less maintenance and will be more reliable both in flight and for dispatch. Studies have shown that a conscientious program of reduced takeoff thrust can reduce engine part replacement costs by up to 40%. Not only will the maintenance costs be reduced, the engine reliability will be improved. Everyone benefits from a program of reduced thrust for takeoff. There are two methods of reducing takeoff thrust. The first method is called derate, and the second method is called the assumed temperature method. We'll be discussing the assumed temperature method later. Briefly though, it's this. The existing full-rate takeoff weight data is used to determine a thrust reduction by assuming the takeoff temperature will be higher than it actually is. Higher temperatures mean lower takeoff thrust. More about this later. What we call derate is another way of operating an engine at less than its maximum thrust. Derate means operating the engine at a defined lower thrust rating, just as if a less powerful engine had been hung on the wings of the airplane. Because it's a separate thrust rating, each derate thrust level will have its own set of performance charts and limitations in the airplane flight manual. When operating at a derate thrust level, that thrust level is now considered to be a new maximum, and it may not be exceeded during that takeoff. When operating with the assumed temperature method, however, the reduced thrust is not considered to be a maximum. It may be exceeded if necessary. Using either method for takeoff thrust reduction means that the airplane will be operating at or closer to the FAR performance limitations.